10 seconds.
This is not going to be easy because I have to switch between both tabs and look at the problem and then come back and answer it.
A master race for the people who have 2 monitors.
All right. A quick word about the nth term test. The nth term test cannot show convergence. It can only show divergence. So keep that in mind as you're looking at these things. The nth term test would actually not help you out here in this one. All right, let's see. Here we go. Ashley up the top. All right. Blake, Maria, David, Melissa. Let's keep it going with the next question. Okay. How come it diverges?
P is less than 1.
Yeah,
P is less than 1. That was a P series. P is less than 1, it diverges. So, all right. Well, yeah, a little bit of shifting around. Alex, now moving up into the top 5. All right. But I'm sure it's close down below. Let's keep going. Logan, got a streak of 3. Awesome. Next question. Ten seconds. Get your answers in. Wow, quite a distribution there. Let's think. That is a geometric series. So, yeah, p-test is not in the form of a p-test. Let me see if I can't. Let's do this here.
Click the wrong button.
Yeah, that is kind of a downside of Kahoot is if you click the wrong button, that's it. There's no going back. Let's try this again. All right, is that coming through, P series?
Yep.
Yep.
That's a P series. If 0 is less than P is less than 1, less than or equal to 1, it diverges. If P is greater than 1, it converges. So the one we just had was a geometric series. Sum from n equals 1 to infinity of a sub 1 r to the n minus 1. That was the form of your geometric series. And the nice thing about geometric series is that if the absolute value of r is less than 1, then the sum, I'll call it s sub infinity, is a sub 1 over 1 minus r.
With the p-test, isn't it if the p was less than 0, it still would diverge?
We wouldn't deal with p less than 0 because p less than 0 would actually put that term in the numerator.
Right, but that wouldn't it still cause it to diverge?
I don't think we think of it as a p series at that point.
Okay.
P series is going to be something that's going to be in the denominator. So we're going to stick with these. All right, let's move over to the next one. Ashley still maintaining that lead. All right, little shake up there. Logan on the hot streak, 4 in a row. Logan.
That first
making it
one's
really
not
close.
fair.
What's that?
The first one was he got it when we couldn't see it.
Jeff and I are just on a
about that.
telepathic link. That's just how it works.
Is that right?
Danya making it close up at the top. All right, way to go. Let's see here. Whoa. All right, so for geometric series, in order for this to converge, R has to be less than 1. In this case, we had R was 1.042, which is greater than 1. Therefore, it diverges. So, bummer. Now, a lot of times people mix up, P series with geometric series. I get it. It's just something that hopefully you get pretty good with practice. The P series will always look like this. It's not going to have anything in the numerator. Well, it could have stuff in the numerator like constants that you could factor out, etc. But that's its general form. Let's see where that one put us. Ooh, little shuffle up there. Still have some of our leaders, but a little bit of a shuffle up there.
Coming in hot on that leaderboard.
All right. Logan, I'm sorry that we extinguished your flame.
No more telepathic, huh?
I just replaced the skates on my mouse, so I clicked like too close over to the other button. That was a total flop.
No, we understand.
Okay. As long as you know the right answers, that's all I'm worried about. Let's keep going. All right. I would accept the integral test. And in retrospect, I wouldn't have minded changing that answer or maybe accepting 2 answers. But the thing that I see the most when I look at that one is the nth term test.
Don't we need to have like an ln of n over n for that to be a integral test?
No. You can integrate that. It's just that it'd be integral by parts, which I don't think most of you realize that you could integrate this, but it'd be an integration by parts problem. It'd be a really tedious thing to do. I don't think most of you are going to take the time on the integral by parts test to do an integration by parts and deal with a indefinite integral, because you'd have to take the limit as n approaches infinity of the integral from 1 to n of ln of x dx, and then integrate by parts and then do it. That's a lot of work. I don't see many of you guys actually doing all that stuff.
Would you say it's valid though?
What's that?
Would you say it's valid though? I mean, if you actually felt like doing it.
It's really being generous.
Okay.
To actually accept that one as credit is really being generous, because I think very few people would actually carry all this work out. So I would stick with the nth term test. And there's a question on the nth term test that we'll answer after the next slide.
Nth term test is just plugging in numbers and seeing where it keeps going, correct?
You should know the nth term test. Oops. But let me get back to that one after the next one. Let's see where we're at in terms of the numbers. Alex still holding on to that lead. Ashley making it close. Spencer on the rise, moving up. Same with Matt. Danya still up there too. So cool. Let's keep it going.
Competition's getting close.
It is. You should recognize the pattern in this stuff now. Seven seconds.
I like the little comments it says after you answer.
Okay, so somebody asked in the chat about nth term test, and I guess I kind of tipped my hand in giving you one that had the nth term test and then asking if it converges or diverge. So the nth term test can only show what?
Divergence.
Can only show divergence. So if you're using the nth term test to prove the convergence or divergence on this, really you're proving the divergence. Now let's keep in mind something about a series and when it converges. A series only converges if the numbers you're adding start getting really, really small, so that you're adding up tinier and tinier numbers. In particular, if that doesn't happen, if the limit as n approaches infinity of your term is not zero, then the series does what?
Diverges.
It diverges. Now, let me give you a choice of A or B. This is what you'd have to do with the integral test. First of all, you'd have to use integration by parts to integrate this. Secondly, you'd have to work with the indefinite part, that is taking the limit of your antiderivative there, to find out that it goes to infinity. Or you could look at the limit as n approaches infinity of this. Where's this limit going? As you approach infinity, what happens to the natural log?
It keeps getting bigger.
Yeah, so this is going to go to infinity. So my question to you is, which one would you choose?
One that doesn't have at least 10 minutes of work.
Yeah, I mean, can anyone say that they would really do all that work when you have this as an alternative? I would hope not. I'd probably grudgingly accept this as an answer, but like I said, I don't think most people understand that there's a lot of work to be done here in order to do it with the integral test. So, Matt, you're also right that if I had a divided by n, then that's set up beautifully for an integral test, because then you can do a u substitution. So that is true, but I did mean what I wanted here, which is just the ln. These terms do not approach zero as n approaches infinity, so it can't converge. Okay, let me get back here. Let's see where we're at. Oh, major shakeup at the top. Spencer on fire.
Need a fire extinguisher help.
All right, let's keep going. Oops.
Big ups.
Sort of. I don't mind giving a freebie. All right. Maybe a couple of you fat fingered the button, but I literally just talked about that one just a second ago in answer to Matt's comment. This one works out pretty easily if you do the integral test, because you can let u equal ln of n, and then du is going to be 1 over n dn. So you can just integrate that. Now, you should have by now have kind of recognized a little pattern in the way we're working on these things. First, we look at the series. Next, we look at if it converges or diverges. So start thinking about whether or not you think it's going to converge or diverge. And let's roll. Six seconds. Get your last two answers in. There we go. Kind of a split there. That was a tough one. Let's think of it this way. Sum of this series, 1 over n, as n goes from 1 to infinity. All right, Spencer, give people a chance to answer. Somebody tell me what they know about this series.
The harmonic series.
It's harmonic series, thank you. So somebody tell me what they know about the convergence of the series. Someone else now.
It'll convert to 0, right?
Well, now that's a good question. If you take a look at the limit of the terms n approaches infinity of 1 over n, you get 0. That's the nth term test, right? Does that series converge or diverge? I mean, what's that tell me? If the limit is approaching 0 of these terms, does that tell me that this converges?
No.
No, it just tells you the limit as it goes to infinity is 0.
Yeah, the nth term test is inconclusive if the limit goes to 0. The only time the nth term test tells you something is if the limit doesn't go to 0. If the limit doesn't go to 0, the series can't converge. Just can't. Now, this one diverges, right? Somebody tell me why it diverges, other than it's the harmonic series.
If it was a piece, yeah, if it was a P series, it's less than or equal to 1.
Is it a P series?
Technically.
It is a P series. Not even technically, it is. P equals 1. So it diverges. So here's probably a good place that you could actually use the direct comparison test.
Wasn't it the integral of that?
No,
No?
it was ln of n over n. Well, let's take a look at these terms. This one diverges, right? But how does ln of n over n compare to 1 over n? This has to be bigger, right? And if this diverges, can this be finite? No. That one has to diverge as well. So that actually would diverge faster than this one, because this is just going to be a bigger term, but it's still going to diverge. So this is actually the direct comparison test. In general, what have I said about you using the direct comparison test?
Be careful with it.
Yeah, I wouldn't use it. I would use like the limit comparison test for the most part. This is probably one example where I could actually suggest you use a direct comparison test. But yeah, this one's going to diverge. All right. Let's see where that puts us. Wow, another major shakeup. Matt's still hanging on. All right, Melissa, well done. Well done. Moving up. Ashley moving up. Alex, got a lead you're building up there. Good job. Okay, a couple more. Wow. Kind of a wild spread around the board on this one. Let's take a look at a couple things. So n equals 1 to infinity, 1 over n times the cube root of n. Okay, so this one's asking you to think about a little bit of algebra. And the idea here is this. You can think of this as n times n to the 1/3 power. What happens when you multiply things with the same base?
They add.
Thank you. They add. So this would be to the 4/3 power. Okay, now, that's not a geometric series. It's just not. So you can eliminate that one. Why would it be an alternating series? What would make a series like this alternate? What do you have to have?
Or negative.
Yeah, you'd have to have some -1 to the nth term up in the numerator there. But this doesn't have it, so it's not an alternating series. I was kind of trying to hint about something here. The nth term test would be inconclusive here. So kind of by process of elimination, you arrive at the p-test. So you had to think a little bit farther down the road than just the fact that it had a cube root here to say that, oh yeah, I guess it is a p-test. All right. Let's see here. All right, let's keep going.
Those other answers.
I did. I was feeling a little bit mischievous.
I mean, it wouldn't be wrong, but it's not necessarily this question.
Yeah. All right, so person who answered in green, I feel you. I really do. It's going to be a much different Thanksgiving this year, etc. Everything is different this year. Let's see. Converges. All right, somebody who hasn't had a chance to participate here, tell me why this converges.
Because p is greater than 1.
Yep. P is greater than 1. Therefore, converges. So if this was to the 3/4 power, then it'd be less than 1 and it would diverge, but it's greater than 1, so it converges. All right, thank you. Let's see where we're at. Alex still out in front. All right. Getting near the end. Nazar, hey, well done. Answer streak of 5. Keep it up. 2 more. Well done. I wasn't sure if you guys would get this one or not, but you did really well. Let's go through the different possibilities. As far as the direct comparison test, in general, I just don't recommend that you guys use that because it's tricky and people mess with it. If you're going to use a comparison test, I try and use the limit comparison test. As far as this one's concerned, it's not in the form of a p-series. So let's review again. P-series, this is a big thing. You don't want to miss a p-series on the exam. P-series look like this. This one looks more like a geometric series. So make sure that you get comfortable with the difference between those two, because those should be kind of slam dunks. If you get something that's a p-series, man, that's a slam dunk. Same thing with a geometric series. So work on those if you're struggling with those.
Wouldn't that be a pretty ugly integral in terms of necessity?
This is, I put these together because technically you could integrate this. This would be another one of those ones where I'm like, all right, grudgingly, I would accept it. I think most people would struggle to try and find the integral.
Isn't the integral?
Yes, you could integrate it.
Isn't the integral a to the x over ln of x, or ln of a? I mean.
Yeah, you have to have an ln of a term there.
Right. Okay.
Okay. Okay, making it close up at the top there, Spencer. I think everyone's in striking distance there, so let's go on to the last one.
I like that way of putting it, striking distance. I also like that fourth answer.
Wow, kind of a split on this one. So for this last one here, let's see. It was this one. Sum from n equals 1 to infinity. It was e over pi, right?
Correct.
E and pi. 3.14, 2.718, etc. That's all we need. Now, why am I concerned about these values? Well, it tells me something important about this. First of all, this is a geometric series. It's just some number to, the nth power repeatedly. So it's a geometric series. This is R. But knowing this much, what does that tell me about E and pi?
R is less than
Sure. Has to be less than 1. Why is that important?
That means it converges.
Yeah, geometric series converge when R is less than 1. Yep. So that one converges. Now, had I written it the other way around, pi over E, that'd be greater than 1, and then the series would diverge. So look carefully at this ratio. I might give you a number, I might not. I mean, earlier I had 1.042 to the nth power. That one converged diverged because this was bigger than 1.
Barely.
But it was bigger than 1.
Right.
Oh, sorry about that, Alexandra. Let's see here. All right, well, what's the final standings? So on the podium with 11 out of 13, Melissa, well done, yay. And Ashley. And the number 1, who is it? Spencer. All right, and some nice runners up. All right, so I will save the data from this and try and give some people some extra credit. Well done, well done. Let's see. Didn't realize that I was recording this whole time. That's okay. Let's just stop.